All right, today we're tackling one of the big ones, the Collatz conjecture. I mean, this thing is legendary. It's so simple you could explain it to a kid, but it has completely stumped the world's best mathematicians for like decades. But get this, a really strange, really complex new paper is making a wild claim that it has the answer. And trust me, it's not what anybody saw coming. So what if this super simple puzzle, the one with just two little rules, wasn't just some quirky math thing? What if it was actually a clue, a little glimpse into the fundamental structure of reality itself? Well, a strange and really complex new paper is making exactly that claim. The authors don't even call it a math problem. They call it a microcosmogony, like a mini creation story told through numbers. Okay, this is going to be a weird one. Let's dive into this argument. Okay, first things first, let's just do a quick refresher on what this problem actually is. You might have heard it called the hailstone sequence, and that's a perfect name really because the numbers, they just bounce up and down all over the place, like hailstones in a storm cloud, before they, well, supposedly, always fall back to Earth. And the rules? They are dead simple. Seriously, you just pick any positive whole number you want. If that number is even, you divide it by 2. If it's odd, you multiply it by 3 and add 1. That's it. Then you take your new number and you just do it again and again and again. And here's the crazy part, the puzzle. No matter what number you start with, no matter how huge, you always seem to fall into this little loop. 4, 2, 1. 4, 2, 1. I mean, mathematicians have checked quintillions of numbers with computers. Every single one of them eventually falls into that loop. But, and this is the big but, nobody has ever been able to prove it. Prove that there isn't some monster number way out there that just goes up forever and never comes down. Okay, and this is where this new paper just throws the old rulebook out the window. It basically argues that we'll never solve this with simple arithmetic. It says we have to look at the problem through a completely new lens, a lens it calls the psi-phi theta framework. And just listen to the language they use here. It's pretty wild. The paper says the conjecture is a profound statement about the fundamental stability of the arithmetic substrate. See that? They're not talking about numbers. They're talking about the arithmetic substrate, the very fabric of math itself. They're saying this isn't a puzzle, it's a test of whether our mathematical universe is stable or not. And here it is. This is the absolute core of their entire argument. The reason this problem is so hard, they claim, is because every single number is living a double life. It exists in two completely different worlds at the exact same time. And these two worlds have totally opposite rules. So what are these two worlds? Well, the paper gives them some pretty poetic names, that's for sure. On one side, you've got the turbulent, noisy sky, and on the other, the crystalline ground. The whole idea here is that the Collatz process isn't just a calculation, it's a battle, a tug of war, between the forces of these two realms. So, the noisy sky, that's the world we all kind of get, intuitively. It's the world of how big a number is, its magnitude. Think of it as our normal real numbers. And in this world, that multiply by 3 and add 1 step, that's the king. That's the force that makes things expand, that makes the numbers shoot upwards and seem totally chaotic. But the crystalline ground, now this is where it gets really weird. This is a world that doesn't care about size at all. It only cares about divisibility. The paper connects this to a very strange area of math called the two-adic numbers, where, get this, being more divisible by 2 actually makes a number smaller. And in this world, the divide by 2 step is the dominant force. It's all about order, structure, and shrinking. So the big question is, how does this poetic stuff connect to actual math? Well, the paper lays it all out in this table, which is basically a Rosetta Stone for their theory. It translates these wild terms, noisy sky, crystalline ground, into real established mathematical concepts. The noisy sky becomes the real numbers we know, linked to the chaotic 3n plus 1 step. And the crystalline ground becomes those weird two-adic numbers, linked to the orderly divide by 2 step. Okay, so if every number lives in these two totally separate, almost opposite worlds, how on earth can you analyze it? That seems impossible, right? Well, the paper says there is a way. You just need a mathematical tool that's powerful enough to see both worlds at once. And that tool, they claim, already exists. It comes from some super advanced work by a mathematician named John Tate. He came up with this thing called the Adele ring.
And what it does is pretty amazing. It's a mathematical structure that literally bundles our noisy sky of real numbers and the crystalline ground of the p-adic numbers together into one unified object. And the paper gives this unified space a name, psi.
But just having one space isn't enough. You need a law, a force that governs it. The paper proposes exactly that, a harmonizing principle it calls phi. They describe it as a laminar force, like a steady current that always ensures the chaos from the sky gets tamed by the order from the ground.
So all of this psi and phi, it's all building up to the paper's grand finale, the actual proof. And they frame the whole thing as a kind of cosmic tug-of-war.
They call it the universal twist and resolution dynamic. The idea is that this isn't just about the Collatz conjecture, it's a fundamental principle of mathematics. A twist introduces chaos, and then a resolution comes in to restore order.
And here's how it maps onto our problem. It's the ultimate showdown. In one corner, you have the twist. That's the 3n+1 step, causing all that expansion and chaos up in the noisy sky. And in the other corner, you have the resolution. That's the divide by 2 step, causing contraction and imposing strict order down in the crystalline ground. And this, right here, is the paper's core claim. The whole argument boils down to one simple idea. The resolution is just fundamentally more powerful than the twist. The orderly pull of the crystalline ground will always eventually win out over the chaotic push of the noisy sky. So how do they claim to prove this? Well, they bring in one final, heavy-hitting concept from a field called Airachelov geometry. It's a thing called height. Now, the best way to think of height is like a master scorecard that measures a number's total complexity across both worlds. It adds up its chaos score from the sky and its order score from the ground. And the paper's big claim is that every single step of the Collatz process, every twist and every resolution is guaranteed to make that total score go down, forcing every number on a one-way trip straight down to the bottom to 1.
So what you're left with is, well, something way bigger than just a number puzzle. This paper tries to reframe the Collatz conjecture as this profound statement, a statement that order will always, always triumph over chaos, because that bias is baked into the very structure of mathematics itself. Now, look, whether this incredibly ambitious, almost philosophical framework actually holds up as a real mathematical proof, that's for the experts to fight over. But it leaves you with a really fascinating thought, doesn't it? What if the answers to our simplest puzzles aren't simple at all? What if they're written in some kind of cosmic code that we're only just now starting to figure out how to read?